Hello guys, we will discuss how to solve a differential equation by using Euler method in numerical analysis, first order differential equation. So the differential equation is given in this format: dy by dx is equal to some function of x and y. dy by dx is equal to differentiation of y with respect to x is equal to some function of x and y. Another thing is given to you or will be given to you, that is the value of y at some x, let's say x0, the value of y at x0, let's say it's y0. This is called as initial value. The value of x0 and y0 is called as initial value. So this type of problem is often called as initial value problem. So now we will discuss how to solve this initial value problem by using numerical analysis or in Euler method. Okay. So let first of all discuss the general rule to solve this type of problem in Euler method. So the general rule in Euler method is y of n plus 1 is equal to yn plus h, I will say what is h of f of xn yn. H will be the space between two x. H will be the space between x0, x1, x1, x2, x2, x3. H is the equal space in between two x. Okay. Let us directly start with a problem by using this. Suppose there is a question: dy by dx is equal to solve dy by dx is equal to minus of y. Initial value is given like this: y of 0 is equal to 1 and h is given as 0.01. This is the problem where differentiation of y with respect to is given. Initial value of x0 and y0 are given, h is given. We have to solve it. Next. Here another thing. Let's see what the things already given in the question. Here x0 is the initial value of x is equal to y0. I have already discussed y of x0 equal to y0. This is the initial value. Here is the initial value 0 in place of x0. So x0 is equal to 0 here. y0 is equal to 1. It is already given here. y0 equal to y of x0. So y of 0 equal to 1. So y0 equal to 1. H is already given as 0.01. It is already given in the question. Okay. So next. What is f of xy? dy by dx is equal to minus of y. As I have already shown to you, dy by dx equal to f of xy. So here dy by dx equal to minus y. So here f of xy equal to minus y. So f of xy will be minus y here. Now x0 is given, y0 is given, h is given, f of xy given. So we will solve it, or we will find the y1. y1 is equal to, according to the formula, see, y of n plus 1 equal to yn plus h into f of xn yn. Here y1 will be y0 plus h into f of x0 y0. Now compare these two formulas. Clear? Next. Y of 1 will be y0 is already given 1 plus h is already given 0.01 into f of x0 y0 means f of xy equal to minus y. So f of x0 y0 equal to minus of y0. So minus of 1. So this is 0.99. y1 is given like this. Now let us find what is y2. As already we have given in the formula, y2 equal to y1 plus h into f of x1 y1. So now y2 equal to y1 is already we have found that y1 equal to 0.99. So we will write 0.99 in place of y1 plus h is same 0.01. Another thing, what is x1? I have already said h is the space between x0 and x1, x1 and x2, x2 and x3 and so on. So if x0 equal to 0 and h equal to 0.01, x1 will be x0 plus h, that means 0 plus 0.01. So x1 will be 0.01 and y1 will be 0.99. So now f of x1 y1 will be only minus y1 because f of xy equal to minus y. So minus y1 is equal to minus of 0.99. Here there is no relevance of x1 at this problem, in this problem only. Okay. So now the value of this will be, I am writing it below, the value of this the calculation will be 0.9801. 0.9801. Similarly, y3 will be y2 plus h into f of x2 y2. Similarly, y2 is already found 0.9801 plus h is already given 0.01. f of x2 y2 means minus of y2 is minus of 0.9801. Okay. So now its answer will be 0.9703. In this way, we can solve the y4, y5 up to like this. This is the Euler formula to solve the differential equation. Okay. Let us discuss another problem. Let us discuss another problem. Suppose the question is like this. Just wait, I am writing the question. dy by dx is equal to y minus x, y of 0 will be half, h equal to 0.1. Let's solve it. Here x0 equal to, as it is given, 0, y0 equal to half, h is equal to 0.1, and the most important thing, f of xy is equal to, as it is given, dy by dx equal to y minus x. So f of xy equal to y minus x. We will solve it. y1 will be y0 plus h into f of x0 y0 y0 will be half plus h means 0.1, into f of x0 y0 means f of x0 y0 will be y minus x, means y0 minus x0, y0 will be half minus x0 means 0. Now half plus 0.1 into half, so 1.1 divided by 2. So the answer will be whatever will be the answer, you will use the calculator, 1.1 by 2. Next, y2 will be y1 plus h into f of x1 y1. Now y1 will be 1.1 by 2 plus h means 0.1, it is already given in the question. Just a minute. (0.1) into f of x1 y1. Here x0 is equal to 0, h equal to 0.1, so x1 will be 0 plus 0.1, so x1 will be 0.1. f of xy means y minus x, so f of x1 y1 means y1 minus x1, so it will be like this, 1.1 by 2 plus 0.1 into y1 means it is already calculated before, 1.1 by 2 minus x1 means I have already said x0 plus h means 0.1. Whatever the answer will be, we will calculate and proceed in this way. Guys, this is the Euler method to solve the differential equation in numerical way. Some points to be made clear here. This is an iterative approach. This is one of the iterative approach, means we will go on doing iterations. Another thing, this is not the exact solution of differential equation. This is only the approximation or approximate solution of differential equation. And as all of we know, whenever there is an approximation, there might be an error, might be some error. But as we proceed to the next approximation, the error might be reduced a bit. So the much approximation we will do, the error might be lesser. Okay. So this is the Euler method to solve the differential equation numerically. Let us put or discuss it once more. The differential equation is dy by dx equal to f of xy, means differential equation is given in this format. Y of x0 is equal to y0, means these are the initial value. Another thing I have already made it clear, and let me repeat it again. This type of problem is also referred to as to be the initial value problems, IVP. So don't confuse that IVP is something different than this. Okay. And another thing, the working rule for Euler method to solve the differential equation is y of n plus 1 equal to yn plus h into f of xn yn, and h is the space between 2x, means x0 x1, x1 x2, x2 x3, h is the space in between x3 x4, h is the space in between the two consecutive x. And the question will be given like this: dy by dx equal to some function of xy. The initial value will be given, y of 0 means x0 here is x0, and y of 0 means that is 1, and here we will say that y of 0 y0 will be 1, and h equal to 0.01. So these are the given data. We will calculate the differential, we will find the approximate solution of this differential equation by using Euler formula y1 equal to y0 plus h into f of x0 y0. y1 in this case y1 equal to y0, it is already given, y0 equal to 1. So y0 equal to 1. H is already given 0.01, h equal to 0.01. f of xy equal to minus y. So here f of x0 y0 equal to minus of y0. So minus of y0 equal to 1. So it equal to 0.99. Here y1 is found. So now we will solve y2, then y3 and so on. The more the approximation, the lesser the error. It's a general rule, not always correct, but generally the more the approximation, the lesser will be the error. So this is all about the Euler method to solve the differential equation. I repeat it again and again that this method may have some error because we are solving it numerically. We are not doing the exact solution. So this method might have some error. Okay. So the most important thing that you have to understand the working rule properly so that you will solve the problems given in the exam efficiently. Thank you. Thank you so much.